All right, so this is chapter 1.2 CFU for concept 1 and concept 2. So the question goes like this. A recent study by the Environment Protection Agency, EPA, measured the gas mileage, miles per gallon, for 30 models of cars, and the results are shown below. And so number 1, construct a dot plot to display this data and describe the distribution. So it's a little bit tedious, but all you have to do is just draw a number line, right? So, and you try to find the smallest and the biggest. So it's about, smallest would be 31.8 and the biggest value is about 41. So you roughly gauge that's the range, and then you put the values in as a dot plot. So the dot plot is shown. Now, how do you describe the distribution? So I want to go back to the G-SOX. G stands for gap. There are not distinct big gaps. There are tiny little gaps, but they're not distinct. S stands for shape, and O stands for outliers, C stands for center, and S stands for spread. So the distribution of gas mileage appears to be fairly symmetric, right? Fairly symmetric, meaning it's the same from the left-hand side and right-hand side when you determine where the center is. So in this case, the center is roughly around 37, right? You see that's all bunched up in the middle, 37. And ranging from what is the spread is from 31.8 to 41 mpg. Are there any outliers? The O. So there do not appear to be any outliers. So number 2, right? Construct a stamp plot to display this data. So number 1, we displayed the data in the dot plot. Now number 2, we displayed using a stamp plot. Now a stamp plot is actually pretty simple. So you need the stamp, right? First of all, the stamp, and then you look from the smallest to the biggest, which is 31.8 all the way to 41. So, and then you put it on the left-hand side and you draw a straight line, separating the stems from the leaves. Right, stem plot usually sometimes is also referred to as stem and leaf plot, and then you put it in order. So like 31.8, you put it as 31, and then you put an 8 on the right hand side. 32.7, you put under the 32, starting 32, and then you put a 7 on the right. So notice that all the digits are actually ranging from smallest to biggest. So you have to arrange them from smallest to biggest. Now, one more thing that you need to add, which is actually pretty important. Now, you need to put a key. A key is to tell the reader how to read the stamp plot. So in this case, the key is 31/8. It actually refers to 31.8. All right, so chapter 1.2, concept 3. So this is a kind of like an extension from the previous question. So the EPA expanded its study to include a total of 50 cars, right? So earlier the previous question has only 30 cars, but now it has increased by 20 cars. So if you notice that the first 3 rows have the same data as the previous question, they only added two rows of new data here. So the results are as follows, right? 1, construct a histogram for this data by hand, and then describe the distribution. Now, by hand, we need to know, there's a big difference between histogram and bar graph. So for histogram, the bars are actually touching. And why are the bars touching? Because the values are actually in an interval. What I mean by interval is, so for example, in this case, I want to make the bar width, right? The bar width to be 2. So in this case, the interval goes like 31.0 to 32.9, 30.0 to 34.9, 35.0 to 36.9, 37.0 to 38.9, 39 to 40.9, 40 to 42.9. Now, reason why I started with 31 is because the smallest data is actually 31.8. All right, and the largest one is, I believe, it's 40.5. No, 41. I believe it's 41. Okay. Oh, no, 42.1. Largest data is 42.1. So now the bin width, right? The bin, which is the width of the bar, bin width is actually 2. So we counted from the data. There's 4 in each. There's 4 of data falls within the first interval. Next 4 more falls in the second interval. Then so on and so forth. We count, and then we put it into its respective interval. Then, all right, we put it in for a histogram. You have the y-intercept, y-axis and x-axis. The y-axis is usually the frequency, right? So in this case, we only need to do intervals increment of 2 to 16 because the highest in this case is 16. There are only 16 numbers between 35.0 to 36.9. And then we just draw a number line starting from 30, 31, 32, 33, all the way to 43. So that should cover the whole 1, 2, 3, 4, 5, 6 intervals. Then you draw the accordingly. So from 31 to 32.9, there will be a bar that goes to, right, the highest is 4, right? The frequency, the height is 4. And then the bars join together, and from 33 to 34.9, and it's also at 4. And the next interval from 35 to 36.9 is 16, and the subsequent interval 37 to 38.9 is 12, and the next one is 39 to 40.9 is 10, and then 41 to 42.9 is 4. Okay, so after we've come up with a histogram, right, that we drew by hand, we're supposed to describe the distribution. So remember GSOCs? Okay, so I don't think there's any gaps in the histogram, but histograms may vary, right? Your histogram may not look like mine, right? So it may vary depending on the bin width. In this case, my bin width is 2. Sometimes some students might do a bin width of 1, 1.5, 2.5. It's different, right? And another point of interest is that the starting values, if it's different, then your histograms may not look the same as mine. Okay, so the distribution of mileage for the 50 cars is single peak. Another way to describe single peak is mound shape, M-O-U-N-D, mound shape. So it's like a hill, right? Just with one mound. And with a slight skew to the right. Some students might write that if they see that. Some students might not think that's necessary, but I put it in here anyway with a slight skew to the right. Now the center of the distribution is approximately. Now you need to really be careful how you say things. When you say, okay, the center is this, is it really or is it about? So sometimes it might be better to just put approximately 37 miles per gallon with a range from 31 to 43. Okay, and there do not appear to be any outliers. All right, part 2, use your calculator. Right, you can actually use your calculator to construct a histogram. You can use the calculators we have in school, in the classroom, to do a dot plot. You cannot use it to do a stem plot, but you can use it to construct a histogram. So try it and see if you can get the same graph like the one that you've just constructed. If not, how can you make your calculator match the histogram you constructed in the previous question? So I would like to show you on the screen right now how I'm using the calculator to construct the histogram. So first off, you need to put in, you go to Stat, Edit, number 1, and then as you can see, I put all the 50 MPG numbers, the data into my list 1, all right? So you have to do that right now if you haven't. So second, quit, come out of it. Now, the first thing you need to do to graph it, you go to second, stat plot. You see the blue, just right, the very first button, y equals. On top of it, it says stat plot. Then you need to click number 1, that's the first plot. You need to turn the plot on. So since it's blinking on, that's okay. So if you scroll down, to the type. Now if you scroll to the right, you see that the one that's the what is blinking right now, that actually the histogram. So you press enter, and then you scroll down. They will ask you, okay, what list are you using? We just put the data in list 1. And so if you press graph, oops, doesn't show up, does it? Then see zoom 9. So it doesn't really show, does it? It doesn't show this. It's not the same histogram. So you have to change, in order to match, you have to change the window settings. So where's the window setting? You see the second button on the top row, window. So if you click on window, now you need to change. You need to change your X minimum to 31, and then change the X maximum to 43, and then, yes, delete, okay. Then the next one down, I'm not sure what that is, but I actually use 2, right? Because every bar, I think that's the bin width. Okay, 2, and the X minimum, the Y minimum should be a 0, and then Y maximum is 16, I believe. So let's put 18 here. And then for the Y, I put a 1, and then next one is a 1. So if I press graph right now, ta-da! All right, so, let's go through that again. So unfortunately, when I annotate, when I write notes on the screen, the calculator function doesn't show up. So, right, first thing you need to do is go to second stat plot, and then you enter for number 1. You got to turn it on. All right, and then actually you have to turn it on first. I believe it's my bad. Turn it on first, and then go to type, and the type is you got to scroll to the right to the histogram. Then you need to scroll down to the X list, and then you put the list wherever you have put your data, and then you press graph. Right now, if you do a zoom 9, right, zoom 9, the window may change. Right, and you may not get the histogram that you have constructed by hand. So to get your calculator to match the histogram that you have just constructed by hand, you need to change the window settings. And the window settings is right here. So go to window, the X minimum is 31, X maximum is 43. And the beam width is 2, Y minimum is 0, Y maximum is 18, and then the Y, I think it's increment. I don't know what SCL stands for, but it's 1, and the X and the ES is equals to 1.